everyone. In this video we're going to look at arithmetic sequences and geometric sequences in terms of depreciation. So did investments and loans in a different video. Now looking at depreciation, I'll just might zoom in. So arithmetic sequences, financial application. For depreciation, we've got flat rate depreciation and we've got unit cost depreciation. So the main difference between the two of them, flat rate is going down by the same amount, usually each year, but whatever the time period is, it could be every month or whatever. Whereas unit cost depreciation isn't affected by time, it's affected by cost of use, so cost of unit use basically. So you could have a coffee machine, so it's depreciating per coffee sold or made. You could have a car, be an example of flat rate depreciation. So maybe it goes down every year, but it might also go down by how many kilometers you drive. Then looking at geometric sequences, we have reducing balance depreciation. So both of these, all three of these are an example of decay. So it's going down each time. So reducing balance is an example of geometric sequences. I've used the example of a computer, but most things depreciate using reducing balance. So computers, cars, if you owned a business and needed some machinery. But, in general maths, you'll be told what type of depreciation it is, or I'm just thinking, you might have to tell from the recurrence relation. So basically, geometric sequence, you can see here, we've got a common ratio. If we go back to arithmetic, and I don't have anything there, but if I scroll up, you can see you've got a common difference. So it's an example of linear decay. All right, let's have a look at a few questions. So just looking at flat rate depreciation, unit cost depreciation, and reducing balance depreciation in this video. And pretty straightforward ones, so not combining any geometric and linear at this point. When we do introduce geometric, it's going to still, with linear, sorry, I shouldn't say with linear, with arithmetic, same thing, but with our arithmetic, it's going to be reducing balance because you're, you might be adding payments to it or something. I'm just trying to think. Well, anyway, we'll do that in a separate video. Let's get started. So just a quick example of flat rate depreciation. So we've got a television. The value of the television at the beginning is $1,500. All right, that's our initial price or our purchase price. And it's going down by $102 each year. So the minus sign tells us it's decreasing in value, and the 102 is how much it is. So we don't say that it's decreasing by negative $102. That negative is implying that it's decreasing. So just remember, if you lost 5 kilos, you don't say you lost negative 5 kilos. The lost is the negative part. All right, so the depreciation is $102 each year. What is the annual percentage depreciation of the television? So because it's an example of arithmetic, we're just going to have the same amount each time. So 102 over 1,500. Then multiply it by 100. So this is a part 3, if you're wondering which question I'm doing. I know I'm rushing a little bit, but you can pause me, you can slow me down, do whatever you like. All right, so 102 over 1,500 times 100 to put it into a percentage, so 6.8%. Use your calculator to determine the value of the television after 8 years. So remember, why do I do that? I need to, oh gosh, so many little icons that are blue. All right, so you could use your recurrence relation. You could make a rule. We could say it's, take away 102 each time. What am I doing? So 1,500 minus 102. So remember, if you use this method, we just need to do it twice. So that's 2, 3, 4, 5, 6, 7, 8. So after 8 years, it's worth $684. The thing with flat rate depreciation, this is why, earlier I said most things depreciate using reducing balance, because eventually we're going, and it was 684, just might write that down now before I keep going. If I keep pressing enter, then, and I probably should have counted, but anyway, after some period of time, it's going to be worth minus money. You can't have an object worth a negative value. So with my television, I bought it in 2013, so it's now 11 years old, and it's still working all right. I probably paid about $1,500 for it, but I do plan on having it until it dies, but it will never be worth zero. Well, actually, probably will if it does die, but it will never be worth negative. I can't, it's not going to cost me money. All right, probably going on a tangent there. Let's just have a quick look at doing it in our sequence. Come on, calculator. Okay. All right, so we're subtracting because it's an example of decay. So we're subtracting 102. So I'm just putting the recurrence relation in here. 1,500, and then we can just press that. So we wanted, what was it, 8 years? And there it is, 684. I would prefer everyone do it that way, and then instead of just kept pressing enter each time, because if you miscounted, or if you kind of knew you miscounted, you're wasting time. All right, just pop it in there and it's done. Remember, if you're given the rule, you could just do it into explicit. All right, so recurrence relation where it says recursive, explicit for your rule. All right, part C, if the owner of the television decides to discard the television once it's first worth less than $100, how long? So we can answer this question as well as the previous one just through this. So if I did it using any other method, it would actually take me longer. All right, so it's first going to be under $100 after 14 years. So 14 years. All right, let's move on. So let's have a look at unit cost. And I might do, I don't think there's one after that. All right, let's have a look at this one here. Maybe a little bit harder than the previous question. So Jasmine owns a cafe that sells juices. Well done, Jasmine. The commercial blender purchased for $1,440 depreciates in value using the unit cost method. All right, so if you're reading an exam or on your SAC and you've got, it tells you what method to use, remember you should have it in your notes. So you should have, I shouldn't say that it's happening, but I did tell you in a previous video to have this page next to this page. All right, so both of them look at the financial applications, and it's just a matter of looking, okay, which one is it an example of? All right, there we go, unit cost depreciation, there it is. And if you need to, you can get, and it's an example of linear decay, it does say that down there, your recurrence relation and your rule. All right, back we go. The rate of depreciation is 0.02 cents per juice that is produced. So the blender goes down in value 2 cents every time a juice is made. The recurrence relation that models the year-to-year value in dollars of the blender is blah, blah, blah. Now, this one here is, so this recurrence relation is actually an example of flat rate depreciation. It's if it's saying it's $144, it's basically saying you've made the same amount of juice each year, which is probably not true. So I think there's a later question where, yeah, so in part D, we're going to, oh, hold on, let me just have a look. Anyway, let's keep going, and then I don't want to read and try to do things at the same time. So if we need to look at the unit cost, we'll do that. So calculate the number of juices that the blender produces each year. All right, so we've got 100, it's going down by 144. So we just need to divide that by 2 cents. So 0.02. Go back to your main screen, 144 divided by, oops. All right, so we've made 7,200 juices. It's quite a lot, isn't it? Well done, Jasmine. Determine how many juices the blender can produce before its value becomes 0. So for this one here, if we were to put in our sequence, so I might just do that. And what did we start off with? 14. All right, so basically after 10 years, it's worth 0. Now that's not 10 juices. This is why it's a bit of a silly question, because it's got unit costs there, but your recurrence relation isn't displayed as a unit in unit cost form. All right, so 10 years. All right, but how many juices? So we know we make 7,200 juices per year. So we're going to do 10 times 7,200. So we're just going to pop a 0 on the end. All right, so 72,000 juices she will have made. Use your calculator to find the value of the blender after 36,000 juices have been produced. All right, so again, we can, because the recurrence relation is in terms of years per year, so it's actually flat rate. Frustrating, but we'll do it unit cost in a sec. So 36,000 divided by, we're doing 7,200 each year. So let's get the calc for that. So 36,000 divided by 7,200. So 5. The value of the blender. And then it's just like, what are we doing? Going back to my sequence. All right, we can just pop that back on. So $720. Now, I don't like all these answers because they all look the same and you start doubting yourself, but we can be confident that they're correct. The recurrence relation above could also represent the value of the blender depreciating at a flat rate. What annual? Well, it is doing it at a flat rate. So 144 divided by times 100. Sorry, does that look like a multiply? And that's just going to be 10%. All right, so it's going down by 10% each year. Now, I'm going to look at this in terms of unit cost. So, actually, I'm just trying to think. I was just thinking then, probably put it in this form, because if we wrote it as a recurrence relation, so B0, that's our initial amount, Bn plus 1 equals Bn minus 0.02. Yeah, that's probably why it was converted to per year, because that's going to take us a very long time if it's just 2 cents. As a rule, we're got 1,440 minus 0.02 n. So you could do it as a unit cost there. Let me just have a look at the previous question to see if that's mini bus $10. Yeah. So here your D would be 10. All right. So they've given us a recurrence relation, but kind of put it into flat rate depreciation form, because we can't assume that you're going to sell 72,000 juices per year. I mean, you could kind of do that for, what word am I looking for? So to predict what might happen, but if you're doing what was actually happening, you would have to use something like that, all right, because it's 2 cents per juice. All right, let's move on to geometric. So that was our 2 examples of depreciation for arithmetic. So for geometric, we've only got 1, which is reducing balance depreciation. And again, this will depend if you've got on how many compounding periods you have, which we'll do in a different video. This is only per year. yearly, compounding yearly. So your R value, if we had to calculate it, remember is 1 minus this time because it's an example of geometric decay. So this part here, remember, is your R. All right, let's have a look at a question. So I'm just going to scroll past all this stuff for a sec. We did some of that, didn't we? There we go. Okay, let's do this question here. A new computer server was purchased for $13,420. The value of the computer server depreciates using reducing balance depreciation method with an annual depreciation of 11.2%. So I'm going to just highlight that. Let SN be the value of the server after N years. So the letter we're using is S. Previously there was B and we've used V. So just take note of what letter you're using, because in your notes you're probably just having one letter, and it does change on the context and you will be penalized if you use the wrong letter. So just be careful with that. All right, so for this one we're actually going to write a recurrence relation. You need to get used to using your notes. So let's have a look at our notes. So R is equal to 1 minus R over 100. So got our initial value and then our value of R. So remember it's, S0, our starting value was 13,420. Sn plus 1 is equal to, so remember we use, the only thing that changes is your initial value and your value of R. Right, so that's important to note. Everything else stays the same. The letter has changed for this question. It's not V, it's S, but you just, wherever you see V, you're going to put S. So let's calculate R. So it's going to be 1 minus our interest rate, where is it, 11.2 over 100, and that was times SN. All right, so we can just plug that into the calculator. 1 minus 11.2 over 100, so 0.888 SN, and then I'll just write that. Now notice you've got your n plus 1 and the n is subscript. It's not this. It's not like you're writing a word. They're not lowercase letters. It's actually subscript. All right, I'm just going to make sure I've got that right because sometimes I don't look at things properly. All right, and there's your recurrence relation. So that was part A. Use the recurrence relation to find the value of the server after each of the first 5 years. So I don't really have the space to do this. Now we've already got S0, so I don't really need to write that again. I need to save a bit of time. So S1 is equal to 0.888 times that. Where's my calc? 888. One more 8, please. Times 3420. All right, 11,916.96. And then we do S2, so 0.888 times. Now, you could just write S1 here because we've already defined S1. I'm just going to take it out and rewrite the number again. But you've already defined it, so you don't really need to write it there. Times times 0.88. Oops, what am I doing? All right, 105.82 to 6, and so on. So what I would do now with my calculator, there's S3. I do need to show the working out, S4 and S5. So I might just, oh no, you can do that. First 5 years, write the values of the terms of the sequence correct to the nearest cent. What is the value of the server after 5 years? Okay, well that was the oh, well, after each of the first 5 years, okay. What is the depreciation of the server in the third year? All right, so let me just do that on my calculator. So how much has it depreciated in the third year? So our S0 is our first year, S1 is our second year, S2 is our third year. So we're going to do the difference between S2 and S3. So I might just write S3 down here. Get it from my calculator. 9397.05. So it's depreciated by, oh, did I miss out on a decimal there? So we just need to do S3 minus S2. So on my calculator, I'm just going to do that. So there's S3, whoops. Oh, I'm just going to do that. Come on. Minus previous one. So it's going down by 1185.21. So that means it depreciated by you don't write the negative sign there, otherwise it's wrong. All right, so technically I should have done S2 minus S3, but the negative is just the depreciation. So it's depreciated by $1,185.21. All right, maybe we'll do one more. Maybe we'll do this question as well. Oops. So you can just stay blue. A car was purchased for $38,500 and depreciates at a rate of 9.5% per year using reducing balance depreciation. So when you see reducing balance, hopefully you recognize it's geometric. If not, it's in your notes. So just make sure you know what sort it is. Let Vn be the value of the car after n years. Write down the rule. Okay, so this time we're doing the rule. So I would go to my notes just to make sure I don't get it wrong. So here's our rule here. So Vn equals r to the power of n times V0. Oops. Where am I going? What was I doing? Oh, it's in here. All right. No, I lost all train of thought. And it wasn't V, was it? No, it is V. Vn equals our value of r, which was 1 minus 9.5 over 100 to the power of n times V0. And I'm just going to do that on the calc. So what you saw before when I went to that other screen is one of my posters coming up for stats. It would have been, I think. Whoops. Here we go. 0.905. Don't forget to the power of n times 3850. You don't need brackets around that because it's a number, whole number. It's not just the number 5 that you're doing to the power of n. 0.905 to the power of n times 38,500. All right, so just getting it straight from our rule on this page. All right, find the value of the car after 5 years. So this is where the rule is good because you can just do V5 and then you just substitute 5 in our rule. So 0.905 to the power of 5 times 38,500. All right, so 23,372. And just make sure you've got your rounding. If you struggle with your rounding, just do more decimal places and then round, just so then it will be counted as a rounding error. What is the total depreciation of the car over 5 years? Round your answer. All right, so over the 5 years, so it started at $38,500 and now it's worth $23,372.42. So we can just do that on the calc. All right, so 15,12758. There we go. So that's how much it's gone down in 5 years. All right, so that's all about depreciation. So in another video, we'll look at reducing balance again, especially with different compounding periods. All right, bye.